Yeah, my name is Guillermo, and I'm going to talk a bit about embedded systems in Elixir and the NERVS project. Uh, Big disclaimer, I only learned about Elixir a year ago. I dabbled with it a little bit for Advent of Code, and I really started going deeper into it in April this year, so I'm by no means an expert. But yeah, I think that also makes it cool, like how could I go from not knowing basically anything to doing something in an embedded system in production. Um, but yeah, just a disclaimer, if you see anything that's not proper practice, it's just understand. Anyway, so I'll talk a bit about the motivation, what was the reason for this project, and why did it get started. Two, how did I get started with Nerves, and also a bit my journey. Three, how to customize a Nerves system, and why would you want to do that. And then last, a bit about communication. How do you communicate with a Nerves device, and what are at least the strategies that I used. So I work for a startup called Clutch. We're a small team of 5, and we have an app that's deep learning based for analyzing badminton, tennis, and paddle video for giving you stats and analytics. So this would be like, this is a professional badminton game, and as you can see, like if you got a good high angle and far away, you can see the whole court and you can see all the players, and then you can produce a lot of stats about like where the players move, what kind of shots they're making, where the shuttle is. But for this, you need a really good angle. It's a mobile app that runs in your phone. You record yourself playing, and then the video gets uploaded and gets analyzed. But in order to get good stats, you need a good angle of recording. So we state that our recording guide is that you have to be recording far away back and also far away up. And for a regular user to carry around a tripod every time they're going to go play, and also have the space and the height to record, it's tricky. So like users have been sending us how they're recording, and sometimes it looks like this, and this is actually a really good effort. Like this gives us a really good result. But other times they can't, and it ends up being like this, where you cannot see the chord, you cannot see the back player because the front player occludes it. So talking to users and seeing, okay, how can we fix this? Because this is clearly not going to work. We decided, actually a bit inspired by the previous picture, that the security camera is there and it works. So why don't we just build a camera that can be set up in the badminton halls or the tennis courts or the paddle courts, and somebody can and then the users can connect to it. So we decided to use for basic prototype. To our requirements or guidelines is that to use very commercial off-the-shelf components. Like we don't need anybody to manufacture anything for us or have any custom solution. Just try to use the simplest stuff. It's fairly complex within a simple device because it needs to record, to upload, to communicate status, to be controlled. So we're assuming that weird states will happen, and they're happening out in the wild where you cannot just SSH into a machine and reboot it or anything. So managing that will be tricky. We also wanted to use an open source platform or an open hardware platform, because if this works and we need to scale it to a custom chip or many more devices, we don't want to be locked into, oh yeah, this product worked for 100 devices, but now it's just clearly not going to work. We'll have to go back to the drawing board. And also we wanted to leverage concurrency, because a lot of the modern chips, they have a lot of CPUs, and we will need to record and upload at the same time and manage status and communicate and detect. We need to do a lot of things. So if we can leverage concurrency and not do this in a serial way, a sequential way, it will be amazing. So there's a few solutions out there. One of the was that I was most interested in before I decided the route we took was Balena. Maybe you've used software for flashing firmware, flashing like a Raspberry Pi SD card, but they also have like a big IoT solution where you can provision and you can manage all your devices, but it gets really pricey really fast. And now they have like a self-hosted thing, but it's like very new, and it's also still within their proprietary ecosystem. So a lot of some of the good features, they keep them for their managed solution, which is understandable, but it didn't seem like it was the right fit. There's this project called Yocto, which is good for customizing your own hardware and flashing it, and it's apparently it's really good, but it didn't take care of all the part of like how do you manage a fleet of devices. AWS has a super comprehensive suite, but for us, like, it was not the good solution because it's vendor lock-in at its most booked definition. So didn't want to go too much into it. And there's also Particle, which does similar things, but you have to use their own hardware, which we didn't want to go into. Google used to have a solution, but in typical Google fashion, they abandoned it. So we decided to, okay, let's do a IoT solution using hardware that we know it's very available and that we can extend at some point. So we ended up going the Raspberry Pi route. And since we wanted to leverage concurrency, for me, at least since I had tinkered with it, Erlang, Elixir, and the Nerves project were a good solution to at least try it out and see what it gives you. Nerves also gives you Nerves Hub, which is like a portal to manage all your devices, and you can send updates over the air and all sorts of things to manage it. There was this talk by Jacqueline Mansley that was also very inspiring for it because she deploys very easily like a simple camera that streams. And I was like, okay, this is like our use case. So it was a bit inspiring to see, okay, this, at least part of it has been done. So to get started, just go to Hex docs. They're amazing, and you can get like really easily started. So you, assuming you have the toolchain and the runtime, you just install the archive of Nervous Drop. You make a Nerves project. You go into it. And then very easily, already with mixed tooling, you can get your dependencies, assemble your firmware, and burn it into an SD card. So that was super easy. And then, so I'll just show, I have this little project here, and it's already burnt into this, into the SD card that's in this little Raspberry Pi in a cardboard case. And then as soon as you plug it in, and assuming you've configured your Wi-Fi, you could just do SH. We're running my hotspot, so it's easy. But it should be available. Otherwise, yeah, there we go. So you already have a Nervous distribution that's running, and you're directly into IEX, and you can see we're in a valid firmware. But for me, one of the coolest aha moments I had with Nerves was like, okay, let's say I've done some changes like to my config or to something, like let's say I replace this for a different UID. So I need to flash my firmware, and oh no, I need to go get the SD card, put it back into my computer, and flash it again. But Nerves gives you like really good tooling so that you can rebuild the firmware, and you can also send it over your local area network without having to get the SD card here and back. So I'll just try to show that, and hopefully it will not break. But yeah, I guess it's building the ISO right now, or it's not an ISO, it's a FW up. That's what it does. And then you just do mix upload, and then it takes care of it. So it connects over the Wi-Fi, and then it uploads the image if it can detect the thing in the firmware. Yep. And it says that it's upgrading partition A because the creators were really smart. And then, as you could see before, we were connected to partition B. So then each time it upgrades the other partition. So if you break it, it will boot into the last known working state automatically. So actually, the SSH failed for some reason because of disconnect. So I don't know exactly what will happen. So I guess I could flash it again. But anyways, let's move on with the presentation. Yeah, so I guess so partition I is still active, so partition B can still be flashed. There was some networking error. Yeah, and then as soon as it boots, I think I'll be able to boot again, but let's just not waste the time. It'll take a few seconds to boot. Anyway, so at this point, I was like super excited. Like I only had to configure my Wi-Fi, and then I could already send updates. So any change I was making, I was like, okay, upload, and test. And that was really nice. At this point, I was really excited. I told my CTO, hey, like this is looking really good. We're gonna have something really soon. So I built this like little prototype, and I was like recording in my house. It was really nice. So here it is. And then I was like, okay, let's try like the recording. Let's try the camera. And And then I saw that none of the camera things were installed. So I was like, no live camera, which is the Raspberry or the official library for controlling Raspberry Pi cameras, no FFmpeg, no GStreamer, nothing. Because Elixir adopts the very bare bones approach, where like you get you get like a super bare bones distribution, and then you can customize it to any need, which makes a lot of sense instead of getting a lot of bloat that you might not need. So you have a very lean distribution with very small surface of errors or different things. So that takes us to customizing nerves. So I was like, okay, it's going to take a little more. Told my CDO, we'll have to go this route. And this is really well documented. I was like, okay, this is going to be crazy, but it's actually really well documented. So basically, the steps are: you need to fork one of the base systems, the one for your chip, I guess. You run build root. You compile a custom base image, and use that custom base image in your project. You're like, okay, what's build root? I didn't know, like I was like thinking when I was printing the presentation, I was like, I know what it is because I've used it, but I don't really know what it is. So I asked GPT. And it's basically like some make files and some utilities that you can use to customize the basic Linux distribution with only the things that you need. Anyway, so I'll show you how not daunting this is. So basically you go here and you do mix nerve system shell. So this is in a customized distribution that I forked. And then you just do mix steps get, and then you just do system shell. And before this used to be a bit nicer. Now you get this scary looking red thing. This is because in OTP 26, they modified something about how you get standard input. So actually, when I was facing this in OTP 26, you would get an error. And a couple of weeks ago, John Carstens fixed it. So now at least you get this until they figure out a better way to deal with standard input. You just copy and paste. But it works really well because this is better than getting an error of like standard input error. Anyway, so since I'm in a Mac, it goes into a Docker container that has the nerf shell. And then I can go into build root, which just go make menu config. And this is build root, which is basically where you can select packages and you're like, oh, okay, I need some media library or something like that. So, okay, I need FFmpeg or I need anything. And then here is where you can customize it, or I need some hardware specific drivers. So here's where you can add anything that you might need for your hardware. You can add it here. And this is build root, and build root takes care of this. And then after that, then you just can make an artifact. So there's a command for making an artifact. So you could make an artifact, and then you can use that artifact as your base image. So actually, it was a lot easier than I thought. So yeah, so I uploaded my first artifact to GitHub, my first artifact ever. I felt really proud. And then you can link to it in your project. So since Mix has like support for installing packages via GitHub, so it was quite easy. But still didn't work. So then you have this string of me adding things. It's like, okay, I need to add this thing in build root and this thing and this thing and this thing, and still didn't work. So I reached out to Frank Hunleth from the Nurse project in Slack. And he was super nice. Like you can see, like this is June 5th, and he already like replied to me. He's like, oh yeah, like we know this problem. We haven't been actively working on it because nobody needed this hardware, but with the new Raspberry Pi cameras use libcamera, which is the new stuff, and mmol is the old camera controller. And so we need to support it in multiple places across the distribution and the build root and the kernel and different things. So he got to it. He pushed a lot of commits in those few days, and he was like back and forth, hey, can you try this? Can you try this? Because you have the hardware that we can test on. So it was super nice, really, really amazing. Like, I was so happy that he was helping me. We even pushed a patch to the build root itself. Well, like I just suggested the patch because I didn't have my email set up to work with patches in Git. That could still completely blows my mind. Anyway, so eventually we had like live camera working. I could record things in the camera. So I went to KVK, which is a badminton club here in Istanbul. Had my beautiful prototype in a clamp, and we could record, and that was really, really exciting. Like I was like, okay, this is working. Yeah, but now in parallel, like while we were looking at things in build root, etc., we're like, okay, how are we going to communicate with this device? So the main idea is like you have an app, you're going to try to connect to this camera. There's going to be a backend that's going to be relaying those commands and authenticating, making sure that everything is good, or telling you that a camera is not available, etc. Right? So I was like, okay, well, we're gonna need a backend. We're gonna need to control these devices. The devices are Elixir, so why don't we use Phoenix as a backend? And Phoenix has channels, which are a fantastic way to communicate in real time. Because one of the things first when I was thinking, okay, how are we gonna communicate with the device? It's like, okay, the device is gonna be behind a network. We cannot really ask everybody in who has a badminton hall or a tennis court to open ports for us. So a good solution, of course, we thought there's MQTT as a good protocol for IoT devices, but I didn't really know a lot about that, but I knew a bit more about Phoenix channels and WebSockets. So I was like, okay, let's do a test with WebSockets. And also I was inspired a bit by a nice blog post by this guy, Connor Rigby, who has done a few things in the Nerves ecosystem, doing a similar thing of like controlling a device for streaming with a backend. So yeah, set up Phoenix channels, super great, explained. And then there was this library called Slipstream that is like it's like a client for a channel for a device like this. So basically, the device itself opens a WebSocket connection to the WebSocket server, which is the Phoenix server, and then it says, "Hey, I'm here. I'm ready for instructions," and then the server will register it and say, "Okay, yeah, you're gonna record now, or you can do something now." So I set up like a tiny demo environment. This one. So here, can you see that? So there's a little demo server here. So you can do IX. So this is like a tiny Phoenix server. And then here I can just do, I can start connecting clients. And then like they can all be connected to the server. They're like, okay, I'm available. I'm waiting for instructions, and then the server can receive them and can send instructions back to them. And this is like super minimal. Like I have both like demo projects. It's like super minimal lines of code that you need. Like this is the server, and this is all you need to handle the connect. And this is just the WebSocket, which is very minimal. And then the socket on the device is also like a very simple Slipstream. It's like a gem server basically. You start, you init, and then you handle connections, and you handle joins, and then you can handle also messages. So with a handle message, you will say, okay, when I receive a start recording, then I do this, or when I receive a stop recording, I do that. So I thought it was really, really amazing how for very little I could get really good real-time communication and also handling disconnects gracefully and all that only with those things. There was a little problem in OTP26 that it was solved, but just like goes to show that I opened an issue, and the next day the guy who was maintaining this opened an issue in Erlang OTP, and then within a week somebody had patched it in OTP26, which was super amazing. But no, and then eventually we put this in a better looking case, and this is in KVK as well. And we got to record things. And now I can't show this, but there's like I can't demo it right now because I don't want to be recording people out there without their consent. But yeah, we have a camera in KVK and a camera in Scoso. And yeah, there's like a Phoenix little live view web app where you can just start them and then it says, oh, I'm initializing, I'm recording, and then you can stop them. So for next time, because I didn't want to take too much time, I can talk a bit more about Bluetooth, because this is something that I've been working on in the last couple of weeks, and Nerves Hub, that is going to be a bit of the next stage, and also how would you leverage all of this to provision many devices, ship them, and how do you manage suddenly maybe 100 devices or more, being, I guess, a small company that we are. Like this has been like, we're a team of 5 and I'm being solo on this project. So it's worked because there's a lot of like a really good community, a lot of heavy lifting done by a lot of people. So just like final takeaways, it always takes more time. And especially with firmware and drivers, like there's just no piece of cake. And like I'm super happy that there's people willing to help and people who know so much about this, because otherwise it would have been like impossible. I think in this stack or in any other stack, because I don't have that knowledge. Also that OTP migration is gonna be messy. Like I had like OTP26 issues in a lot of places, but I had to be on OTP26 because the new changes that Frank introduced were for targeting OTP26. But also just the Elixir community is awesome. Like it's like the help I've been receiving is all along the way has been super, super useful. I would have been super stuck. So just a few shout outs of the people who helped me out. The last guy is from Svenborg, so I told him he should join us in a few times if he can make it. But anyways, thank you very much. And any questions, I'm happy to hear.
What did you run on the client devices? And you said you wanted to make an app for the devices. Is that a web app or what?
No, it's an Android and iOS app. So right now we use a web app to communicate with the cameras that are out there, but we're implementing the communication between the mobile apps and the backend. Yeah. Yeah, so the idea is that you come into a sports hall and then there's a camera there and you're like, you search for it and it's there, like so you can locate it via Bluetooth and then you can connect it via the backend.
Was the data channel also for submitting video or is that for the commands?
It's only for the commands. For the upload of the video, the backend sends a pre-signed URL, and then the device uploads it to S3 directly.
Are you going to do sort of web channel, WebSocket connection from iOS and Android devices, some libraries for doing that, or is that?
No, I think at least for now it's just a simple HTTP API. Like they only need to give basic commands. Though in the little web app it's live view, so that is definitely everything.
Have you done any thoughts regarding if the tennis hall loses the internet connection, and how you can still have the system functioning?
Yeah, like I've implemented some basic redundancy. So there's a little persistent storage in the device to record, like if power goes out or internet goes out, it can have a basic retry. But I've also, like for now at least, determined that if after 2 hours it can't retry, it just resets to the default state.
Yeah, but more like, I'm just wondering if there would be a way, so let's say that there's a hall that is disconnected from the internet.
Yeah.
Some hours or something like that, and you would still be able to control it with your phone.
No, and yeah, for now at least it's not contemplated. Like if they don't have internet, then you just can't detect it. You'll just get a message like you will still be able to see the camera because it will be available via Bluetooth, but the backend will say this camera's unavailable.
Okay.
Yeah.
That's the thing you're working on with Bluetooth. You can see the camera.
Yeah. So with Bluetooth, yeah. So we're using Bluetooth beacons to say like broadcast availability. So then you can see what devices are around you, and then you can pick which one you connect to.
So you cannot control the device with Bluetooth?
No, it's only for discovering. It's only for knowing what's there. Yeah.
So Docker Hub, that's outside your sphere of influence. So
Docker Hub?
Yeah, it's outside your sphere of influence. So if they were to close down tomorrow, would you have any ability to put up your own Docker Hub?
Oh, you mean Nerf's Hub?
That instead of the official.
Do you mean Nerf's Hub? Or
Sorry, Nerf's Hub.
yeah, it's self-hosted actually. Well, so I think they had a 1.0 where they hosted it, but the 2.0 is self-hosted. Yeah, and the 2.0 is like a bit in the works. It's like a bit of a refactor of some things, but it's the basics are the same. Yeah. And it's basically like a Phoenix server with a few more things. And it's all open source. Well, thank you very much for listening.